Good day, learners. Today we are going to study the relationship between the radius and the chord. So before we proceed to this one, let's have our review. Okay, we have the central angle or subtended angle, and then we have the measure of the arcs. So in here, class, I'm going to make here an arc. Let us call this arc as arc GH. So from here up to here, we have GH, and that is an arc, a minor arc. So this one is the center of our circle, and the name of our circle is circle O there. So the central angle, which is called sometimes the subtended angle, is this one, central from the word center. So that thing there, that angle there is angle GOH or HOG. In short, that is the central angle. Now, sometimes the central angle, you are given two letters here, arc GH, they put the measure of, like that, the measure of arc GH the same as the central angle. So we have the central angle here, which is sometimes written as M, GH, and an arc symbol above. So if the measure of this central angle is 40 degrees, this MGH is equal to 40 degrees. So this angle here will tell you the measure of GH, because usually they are going to put the degrees here, MGH, two letters and an arc, and you'll be confused. What is that one? That is also the measure of the central angle. Let's have now the radius and the chord. So I'm just going to erase this one, so you'll be confused. Okay, one more. So we have here the center. There is a theorem there that if the radius, where's the radius of this one? We can have our radius here. This radius, we can have our radius there. And the radii here are all equal. The radius here is equal to the radius there. They are all equal. If they are not equal, it will not be a circle anymore. And we have a chord here, chord FG. So we have a chord FG, written as GFG, and then we have a line there. Symbol for line segment, no double arrows there. If you have a radius here, there's a theorem there that if the radius is perpendicular to the chord, then this radius bisects our chord into two equal parts. Anyway, bisect means two equal parts. Now, if you have a radius and your radius is not perpendicular like this, so it's not perpendicular. If that one is not perpendicular, this radius is not perpendicular up to here's the radius. This angle and this angle here, they are not equal to 90, because if they are perpendicular, this one will be 90 and the other one will be 90. In this case, maybe this is 100 and the other one is 80 degrees, because the total is 180 degrees. So if the radius is not perpendicular, the length of our chord will not be equal also. F to this point and from this point up to that point, they are not equal. Okay, they will be equal only if this one is perpendicular to the chord. Okay, let's have this one. Now, you can see now that our radius is perpendicular. By just looking at it, we know that OD is perpendicular to this AB chord. Now, let us identify these lines. This O to A, which is a line segment OA, is the radius. Line segment OB is also a radius. OD is also a radius. So we have three radii here, OA, OD, and OB, and they are all equal. AB is our chord, and when the radius is perpendicular to this chord, I'll write the symbol of perpendicularity. This was the symbol of perpendicularity. Means if one line is perpendicular to the other line, the measure of the angle is 90 degrees. We have a straight line, and we know for a straight line it measures 180 degrees. So if we have already 190, then the other one is also 90 degrees. So we have here a right triangle AOC and a right triangle on the other side BOC. So we have two right triangles here. If this radius is 90 degrees or perpendicular to the chord here, then the AB chord will be bisected. Meaning, if this one is point C, then A to C line segment now is equal to line segment from C to B. They are now equal in length. So if your chord AB is equal to 20, how much is this one? So it is half of 20. So this one is 10 and the other one is 10. Okay? If the length of A to B is 16 centimeters, then you have 8 here and 8 there, provided that the radius is perpendicular to our chord. Because here, if that one is not perpendicular, this one is not perpendicular, maybe your radius like that, and the angles here are not perpendicular to this line, then we cannot say that from this point to this point is equal. From this point up to this point, they will not be equal anymore.